Hello viewers, I am Kausalya. Today we are going to solve problem number 16. The problem is a linear time invariant system is characterized by the homogeneous state equation and this is the respective equation. Compute the solution of the homogeneous equation assuming the initial state vector. So this is your initial state vector. Here the solution is the homogeneous equation is given by x of t is equal to e to the power at into x naught, whereas e to the power at is given by pi of t, which is equal to inverse Laplace of pi of s, which is equal to inverse Laplace of si minus a the whole inverse. So from the problem, so this is our given problem, right? So from the problem, the value of A matrix is this one. So A matrix is given by 1, 0, 1, 1. Okay, what we actually need? We need Si minus A the whole inverse, and that too we need a inverse Laplace of that. So Si minus A is given by S into identity matrix minus A. This is your A matrix. So when you multiply this S with the identity matrix, here we will be having S0, 0S minus of this term. So when you do subtraction, S minus 1 becomes your first term and 0 minus 0 is again 0 and 0 minus 1 is minus 1 and S minus 1 is S minus 1 here. Right. The next step is we are going to find Si minus A the whole inverse. So this is given by adjoint of Si minus A divided by determinant of Si minus A. So adjoint of Si minus A is given by, how to take adjoint for a 2 by 2 matrix? Here just we have to interchange these two terms, right? So here both the terms are same. So here even though after we interchange we will be having the same values here. And the next thing is we have to change the sign of these two elements. Right, so minus 0 doesn't mean any value. So 0 remains 0 and here this minus 1 becomes plus 1 here. Right, divided by determinant of Si minus A. So when you take determinant, what happens? S minus 1 into S minus 1 minus 0. Right, here S minus 1 into S minus 1 minus 0 into minus 1 is 0 here. So S minus 1 into S minus 1, we can write it as S minus 1 the whole square. Right. So here we are getting the answer as S minus 1 whole square. Right. So the next step is, here I am bringing this denominator term for the each and every individual term which is present here. Right. So that becomes S minus 1 divided by S minus 1 whole square. 0 divided by S minus 1 whole square, right? Similarly for 1 and similarly for this S minus 1. So here in this case, this S minus 1 and this S minus 1 square get cancelled and the remaining term will be 1 by S minus 1. Right. And here 0 divided by anything is 0 and again 1 divided by this S minus 1 whole square, and here again these two terms cancel each other, therefore 1 by S minus 1. So this is our Si minus A the whole inverse matrix. So e to the power at is nothing but inverse Laplace of Si minus A the whole inverse, right? Just now we had calculated the value of Si minus A the whole inverse. So just substitute the values here, right? They are inverse Laplace of this Si minus A the whole inverse. So when you apply inverse Laplace transformation, so 1 by S minus 1 can be written as e to the power t. And similarly, 1 by S minus 1 whole square is t into e to the power t. And here again 0 becomes 0 and 1 by S minus 1 is e to the power t here. Right. So the solution of the state equation is, so x of t is equal to e to the power at into x naught. Right. So this is our e to the power at matrix. So just substitute it over here and the value of this x naught is given in the problem. Right. So when you multiply these two matrices, our final matrix is e to the power t into t into the power, t into e to the power t, right? I hope you people are familiar with the matrix multiplication, right? If we have two matrix of different formats, that is, you see, here we are having a 2 by 2 matrix, right? And here we are having 2 by 1 matrix, that is 2 rows and 1 column. So here this 2 and 2 cancel each other. So the final output matrix will be of 2 by 1 matrix. So you see here we are having a 2 by 1 matrix, right? If you people have any doubt, just cross check like this. So here comes the end of the problem. This is a very simple problem. Kindly go through it. If you have any doubt, let me know in the comment section. Thank you.